So what we have here is a solution of copper sulfate. Copper sulfate. And copper sulfate is an ionic compound. The copper loses 2 electrons to the sulfate. So the copper has a positive 2 charge, and the sulfate has a negative 2 charge. This is a cation, this is an anion. So you can imagine it's very easy to dissolve it in a polar solvent like water. So this is an aqueous solution. We are dissolving it in water, and it actually does have this blue color. So one way to think about it is this is a bunch of copper cations dissolved in water and a bunch of sulfate anions also dissolved in this water right over here. Now we're going to do a little bit of an experiment. We're going to take some solid zinc, and solid zinc would have this kind of metallic gray color. We're going to take a powder of solid zinc metal and throw it into this solution and think about what is going to happen. So that's solid zinc right over there. So zinc in the solid state plus this inside of this solution of copper sulfate, what do we think is going to happen? And I actually encourage you to pause the video, look at this table of electronegativities, and look at what's going on here. Think about who has the electrons and who might want the electrons, and then think about what you think is going to happen. Well, let's look at the electronegativities right over here. Copper is more electronegative than zinc is. And so if there was a way for copper to take electrons from zinc, it would, especially this copper right over here. These are positively charged coppers. They would love nothing more than to take some electrons and become neutral. And look, there's someone to take those electrons from. And so what you get is a redox reaction, and we'll look at the half reactions in a second. You get a redox reaction where the copper takes electrons from the zinc. So it becomes solid copper, neutral solid copper, and the zinc loses those electrons to the copper, and so those become zinc cations, or you could think of it as zinc sulfate dissolved in the aqueous solution. So let me write that down. Zinc sulfate, and that has a negative charge still, and it is in an aqueous solution. So what will this actually look like? So let me put another glass here. So this is before the reaction starts. After the reaction, it's going to look something like this. Zinc sulfate is actually a clearish looking liquid. So let me draw that. The liquid will actually become clear. So zinc sulfate is a clearish liquid. Instead of having solid zinc here, now you're going to have solid copper. Now you're going to have solid copper that will have precipitated out of the solution. So that's pretty neat. And just to make sure that we understand it in terms of oxidation and reduction, let's think about the half reactions here. Let's think about the half reactions. So let's think about the half reaction for zinc. So zinc here, solid zinc. Right over here, it has a neutral oxidation state. It has no charge. And then we end up right over here with zinc that has a positive charge, a positive 2 charge. So you get to zinc with a positive 2 charge. So what happened right over here? It lost electrons. It got oxidized. So it lost 2 electrons. The zinc got oxidized. The zinc got oxidized. And then what happened to the copper? Well, the copper started as a cation. So it started in the aqueous solution, and then it gained 2 electrons. Each atom or each ion of copper gained 2 electrons. And then we end up with copper. In the neutral copper in the solid state. So its oxidation number was reduced. It became more negative. So we could say that the copper was reduced. Copper reduced by the zinc oxidized by the copper. And we see that the sulfate, its charge didn't change. And when you're dealing with an actual ionic compound, the oxidation state is its actual charge. It's not hypothetical anymore.